why my smart board was having such a problem today. Now I know what's going on. Here we go. All right, so many triangles are not right triangles. Would you agree that most triangles are probably not right triangles? So therefore, you can't use SOHCAHTOA and you can't use the Pythagorean theorem. And we learned what happens when you have an angle and its opposite side. We use the law of sines. Well, what if we don't have an angle and its opposite side? What if you have side, side, side? What if you have side, angle, side? That creates a whole different situation. I'm going to take these sides, side A, side B, and side C, and I would like to say something about all three sides. I'd like to come up with a formula that relates all three sides together. The problem is as I draw a right triangle, notice how it divides C up. And it doesn't divide it evenly. So I'm going to call this side X. If the entire length is C, anybody know what the other side would be? C minus X. So I don't really have what I want, but I'm gonna try to come up with something that can relate sides A, B, and C. I'm going to call this H, and I'm going to write two expressions using the Pythagorean theorem. Give me one expression that involves the Pythagorean theorem. Good. H squared plus X squared is B squared. Give me another expression that involves the Pythagorean theorem. Good. Looks like a bunch of garbage, but we'll get it to work out because we are excellent mathematicians. I don't really care for the fact that I have H's and X's in there. I want the H's and X's to go away because in a general triangle, we're not given H or X, are we? We're given A, B, and C. So we want to get rid of H, we want to get rid of X. Notice these both have what? H squared, don't they? So I could say H squared is equal to exactly. They both have an H squared. I'm going to take just a slightly different approach than I did the hour earlier today. If this is equal to H squared, I can substitute it right in there, can't I? Notice how my H's will disappear altogether. So we have this expression now, B squared minus X squared
equal to B minus X squared plus A squared, or minus
plus C minus X quantity squared is equal to A squared. So I just took this and I put it in for H squared. My goal, what I accomplished is I got rid of the H's. What do I still have that I need to get rid of? X's. Let's see what happens here if we can maybe get rid of some of the X's. B squared minus X squared. What happens if I square that out? What are you going to get?
C squared minus X plus X. Oh my God.
If you multiply this out, don't we have to FOIL that? Are we going to get a minus 2cx in the middle? Then plus x squared? Hey! What happens? What cancels? The x squareds go away, don't they? The x squareds are gone. Yeah, I could actually write this as a squared is equal to b squared plus c squared. That looks pretty nice. But then I got this minus 2cx. And remember, our goal is to get rid of what? The x's and the h's. We're almost there, aren't we? Like we just got to get something to go in for x. Notice where x lies in the setup of the problem.
the right side or left side of the triangle?
Oh, it's the cosine.
Yeah, it's called law of cosines A, right? Yeah, we could just write an expression that says the cosine of angle A is equal to what over what? X over B, adjacent over hypotenuse, X over B. And if you multiply both sides by B, you get B times the cosine of angle A is equal to X. So this thing can substitute right in there. So I just multiply both sides by B. So my new equation is A squared equals B squared plus C squared minus 2BC times the cosine of angle A. That's the law of cosines.
Minus 2BC cosine of A.
Yeah. Now you can write it three different ways. Flip it over. One way to write it is this. A squared equals B squared plus C squared. And that looks really nice, doesn't it? That's if you have a right triangle, we would have like, say, C squared is A squared plus B squared, right? But when you don't have a right triangle, you need to subtract off 2BC times the cosine of angle A. So that would be if we're trying to solve for side A, we would use that formula. So I'll switch it up. Suppose we wanted B squared here. Anybody know what would come next?
A squared
A squared plus C squared minus
2AC cosine of B.
Good. If you notice, this is the pattern you should see develop, that whatever numbers you're squaring right here, those are the numbers that you're multiplying right there. And whatever side you're solving for here, that's the angle that you have over here. So who could tell me what the final formula would be? C squared equals? Oh, doesn't that look nice? Minus 2AB cosine of C. Good. Law of cosines. Looks bad, a lot better than what it looks like. Okay? All right? A lot better than what it looks like. So let's try one problem here, and then we'll do a problem in your assignment, and you'll be good to go. Angle A, angle B, angle C. Sí, señorita. Yep. Okay, classify the triangle. What kind of triangle is it? It's a side angle side. A plus for Marissa today. Gold star. Way to go. All right. So Marissa says it's that. And so I'm going to go to my decision tree right here because it's super helpful. And look what it says. It says if you're given side angle side, it says just use the law of cosines. It's one solution. We don't have to worry about two solutions, no solution, none of that stuff. So we just start by using the law of cosines. It gets slightly complicated after we find the first thing, but we'll talk about it. You're in good hands. So can anybody guess what? I'm going to write this stuff down first. I got angle A is 26 degrees. I've got side B is 12. And I've got side C is 15. So can somebody tell me what is the next piece I want to find? Why? Yeah, because I have angle A, I want to find an angle and its opposite side. Because then you get to use the law of sines, right? And that's easy. So we want to find side A. So which formula up here do you think I should use? A squared. Let's write it out. A squared equals 12 squared. Please speak in unison.
Plus 15 squared.
Excellent. Let's have 8 people speak in unison.
Times 12 times 15 the cosine of 26.
It kind of fell apart there a little bit, but yeah, I get it. So here's the cool thing, is that these new Texas Instruments calculators everybody's using, you can just type the whole thing in.
Oh my god, smart enough?
Yeah, oh yeah, it understands the order of operations. 12 squared plus 15 squared. So I just type it exactly like it looks. Minus 2, parentheses 12, parentheses 15. Whoop, got a 1 out of that. That ain't going to work. And I got cosine of 26. And because I teach a different class, I'm going to check my mode, make sure I'm working in degrees. I am. And then I press enter. Is that my answer?
No.
Why?
Because you need to create the square root of it.
That's a squared. So let's square root it to find our answer. 6.74. Does it seem like that should maybe be a shorter side? Yeah, because it's, yeah.
And then we do the equal.
Okay, pause. Okay, my good friend Easton just said, let's do the easy part. And he's right, but you do have to be a little bit careful, folks. And I got to explain to you why. Look at your decision tree and see what it says. It says one solution using the law of cosines to find the missing side. But when you use the law of sines to start finding one of the missing angles, because that's what we're going to do now, right? Law of sines. Sine of 26 over 6.74. What should we use angle B or C? Which one should we find? This tells us. It says when you use the law of sines, start with the angle opposite the shorter of the two sides. So let's look here. I've got this one is 6.74, and I want to, so which one should I find? Should I find angle B or angle C? B, because it's opposite the shorter of the two sides.
If we do it C, did we get it wrong?
You will in this situation. I'll show you why. Yes, yep. Okay. Watch. Sine of 26 over 6.74 equals sine of, and now we have to choose. Do we want to solve for angle B or angle C? You do the one that is opposite the shorter of the two sides. So B is opposite 12, C is opposite 15. So sine of B over 12. Okay, so let's talk about y real quick. I would say only 50% of people understand this, so try to follow through with me, okay? True or false? A triangle can have more than one obtuse angle. False. Every triangle can only have one obtuse angle if it has one, right? So, true or false? If this triangle has an obtuse angle, it would be angle C. True, because angle C is going to be the largest one, right? Now, when we use the law of sines, sine doesn't know the difference between acute or obtuse, does it? It doesn't. So sine can't find obtuse angles. It doesn't know how. It's stupid because sine's positive in the first quadrant where they're acute, and it's positive in the second quadrant where they're obtuse. It doesn't know the difference. It doesn't know the difference. So, therefore, we find the acute angle. If C could be obtuse, the B has to be acute. So, what do I do to solve? What do I do to both sides? Yep. So, 12 sine of 26 divided by 6.74 is equal to sine of B. So, I go to my calculator. I turn it on. I press 12 sine of 26, and I divide that by 6.74. And I get that. Is that my answer? No, you're finding an angle, so what do you got press? Inverse sine of that answer, and I get 51.30. From 180, yeah, 180. What up, Easton?
Yeah, so I tried just for fun to see what happens when I do. Plug in C instead of B. I got a little thing called a domain error.
let's talk about that later, because I don't know why that should.
I fucking angle instead of sine B over 12, I did sine C over 15 just to see what happens.
I think it should still work out. Let's check that. Okay. So I get 102.7 degrees. So this will kind of help you all the way. Did I come up with an obtuse or an acute? If you, instead of finding B, if you would have found C, here's what it would have given you, okay? Instead of coming up with 102, if you would have found C right away, it would have given you 77.3.
I see where I went wrong. I did 6.4 instead of 6.74.
Got it. And if you did, watch this, if you do sine of 77.3 and you do sine of 102.7, look at what you get. You see, sine doesn't know the difference between 77.3 and 102.7. That's why you have to follow the directions. Take out your homework assignment. We're going to do one problem together there. What's that?
When you get home today, you can tell your wife she's a cute angel.
She's a cute angle. I like it.
That was Marissa's joke. Yeah, for real.
Marissa, you have great jokes.
I think I like this every single time I get it. I forget all the little shit. I went to just design that and then I was like, oh, but I need your help with me too. First is wait. Oh god. Oh, okay.
Turn to your homework and please look at example 1. We're not going to do example 2 that's in your notes. And in this one, I have side A is 10. I have side B is 8. And I have side C is 12. We're going to do that here in a little bit. Okay? Classify the triangle. What kind of triangle is it? Side, side, side. I'm going to go to my decision tree. Please pay attention because people got confused with this the other hour. Side, side, side. Be confident there is one solution. Use the law of cosines. You can cross off that next section where it says when you use the law of sines, you can cross that off. Just disregard it. Don't do that. Doesn't really matter. Instead, go here. It says just start by solving the angle opposite the largest side. So when we have side, 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 we start by finding the angle opposite the largest side. C. True or false? If this triangle has an obtuse angle, it would be angle C. Obtuse angles, do they happen in the first quadrant or do they happen in the second quadrant? Is cosine positive or negative in the first? Positive or negative in the second? It's negative in the second. See, cosine knows the difference between acute and obtuse. Cosine's a different breed. Yeah, thank you. So we're going to find angle C. So I need to use the formula C squared is equal to A squared plus B squared minus 2AB times the cosine of angle C. Notice what's different about solving here is that this angle C, that's the variable I'm trying to solve for. So I've got numbers that go in for all the other variables. What is C squared? 144 is equal to 100 plus 64 minus 2 times 8 times 10, right? What's 2 times 8 times 10? 160 cosine of C. Here's what people do wrong on the test. They do it all the time. They take 100 and they add 64 and they then subtract 160. And so they write this as 144 equals 4 cosine of C. Can I do that? Can I just combine all those together? Why not? Because it's time to cosine of C. Like, you got to subtract those over, right? So I'm going to take 144, and I'm going to subtract 100, and I'm going to subtract 64. So if I subtract those over, I get negative 20. And then what do I have on the right side? Negative 160 cosine of C. How do I solve for cosine of C? What do I do to both sides? Divide by negative 160. And you get 0.125 is equal to the cosine of C. Please be careful with your positives or negatives because they matter a lot. 0.125, is that positive or negative? So if cosine is positive, is that the first quadrant or second quadrant? So it could be acute or obtuse. So I go to my calculator and I cosine inverse 0.125. And I get 82.82. Now, look what happens if I did a cosine inverse of negative 0.125. Notice I get an obtuse angle. So you got to be careful with your positives or negatives when you're working with cosine. Okay, so now I got to find A or B. And at this point it doesn't matter because your biggest angle is solved for. We know that these are both acute. And the law of sines has no problem with acute angles. So, Avery, would you like to find A or B? She wants to find A. So we'll do that. So I have the sine of 82.82 divided by what? 12 equals the sine of A over what? 10. To solve, I multiply both sides by 10. 10 sine 82.82 divided by 12. Yep, got to inverse sine that guy. 55.77. Do I have to use the law of sines to find the next one?
No.
How about the Pythagorean theorem?
No.
No, you're working with angles. 180 minus the 82.82. And then minus 55.77. I get 41.41. Last thing, we now want to find the area. We're going to let Alyssa choose. Alyssa, do you want to use angle A, B, or C? You choose. She wants to use B, and we know that B is 41.41 degrees. Does anybody remember what we type into our calculator to find? Oh, we didn't learn this. We didn't have class on Friday. Super easy. You want to find the area of a triangle? That whole like 1/2 base times height? Here's all you got to do. 1/2 times one leg, say 12, times another leg, 10, and then you times it by the sine of the angle between them. Yeah. So you could actually choose any one you wanted to. You just switch up the legs and the angles then. It's just two sides and then sine of the angle between them. 1/2 times both sides times the sine of the angle between them. That's all you do. 39.69. Yeah, 0.5 times 12 times 10 times sine of 41.41. 39.69.
Yeah.
That's it. You don't have to do example 2. You have 6 problems. That's pretty minimal.
You have to do number 2?
You don't have to do example 2. We kind of did an example of our notes to satisfy that. Do find the area. I'll bring up the answer key so you can check them during class. Please find the area. If you mess up the area a couple times, don't worry. It's easy to do. We'll just figure it out. But it's a good way to check your results. And we'll talk a little bit more about the area again tomorrow because we didn't have that lesson on Monday or on Friday. So, all right, I'll bring up the answer key. Get to work.